The National Electrical Code, or NEC, does not mandate a specific orientation such as all switches down for 3-way and 4-way switches when the controlled light or outlet is in the off state. The NEC does stipulate that single pole and double pole switches must be in the off position, which is typically down when the circuit they control is de-energized. This requirement stems from the straightforward, one-directional control these switches exert over electrical flow. 3-way and 4-way switches, however, operate with greater complexity. They possess two sets of terminals, enabling them to manage electrical flow in two directions. This dual-directional capability is crucial for multi-location switching circuits, where a single light or outlet can be controlled from several points. Due to this design, it is not consistently feasible to have all switches in the down position when the light is off in a multi-location setup. Consider a scenario with two 3-way switches. To energize the light, one switch must be in the up position, while the other is in the down position. This illustrates the inherent variability in switch positioning within such circuits. While a uniform down for off configuration might be preferred for its intuitive nature, the NEC prioritizes functionality and safety over such aesthetic consistency in the context of 3-way and 4-way switches. The code emphasizes the importance of understanding the potential risks associated with electrical work and strongly advises homeowners to take appropriate safety measures. Firstly, always to energize the circuit at the breaker before performing any electrical work. This is the most critical step in ensuring personal safety. Secondly, use appropriate personal protective equipment, such as insulated gloves and safety glasses. Thirdly, verify that the circuit is de-energized using a reliable voltage tester before touching any wires or components. Fourthly, never work on electrical circuits when standing on a wet surface or when your hands are wet. Fifthly, if you are not comfortable working on electrical circuits, hire a qualified electrician to do the work. Sixthly, be aware of the potential hazards of arc flash and electric shock. Seventhly, follow all applicable codes and regulations when performing electrical work. Eighthly, use only approved and listed electrical components. Ninthly, properly ground all electrical equipment. 10thly, inspect electrical systems regularly for any signs of damage or deterioration. The operation of 3-way and 4-way switches depends on internal mechanisms that create different circuit paths. A 3-way switch has 3 terminals, a common terminal, and 2 traveler terminals. The common terminal is connected to either the power source or the light fixture. The traveler terminals are connected to the traveler terminals of the other 3-way switch in the circuit. When the switch is in one position, the common terminal is connected to one traveler terminal. When the switch is in the other position, the common terminal is connected to the other traveler terminal. A 4-way switch has 4 terminals, 2 input terminals, and 2 output terminals. The input terminals are connected to the traveler terminals of the 3-way switches. The output terminals are connected to the traveler terminals of the other 3-way switches. A 4-way switch essentially swaps the connections between the traveler wires. When the switch is in one position, one input terminal is connected to one output terminal and the other input terminal is connected to the other output terminal. When the switch is in the other position, the connections are reversed. Understanding how these switches work is essential for troubleshooting and maintaining multi-location switching circuits. For example, if a light controlled by 3-way switches is not working, the problem could be a faulty switch, a loose connection, or a broken wire. To troubleshoot the circuit, you would need to use a multimeter to check the voltage and continuity of the wires and connections. If a 3-way switch is faulty, it can be replaced with a new 3-way switch. It is important to ensure that the new switch is wired correctly. The common terminal of the new switch should be connected to the same wire as the common terminal of the old switch. The traveler terminals of the new switch should be connected to the same wires as the traveler terminals of the old switch. If a 4-way switch is faulty, it can be replaced with a new 4-way switch. It is important to ensure that the new switch is wired correctly. The input terminals of the new switch should be connected to the same wires as the input terminals of the old switch. The output terminals of the new switch should be connected to the same wires as the output terminals of the old switch. When working with electrical circuits, it is important to follow all safety precautions. Always turn off the power to the circuit before working on it. Use insulated tools and wear safety glasses. If you are not comfortable working on electrical circuits, hire a qualified electrician to do the work. In residential electrical systems, understanding the applicable codes and regulations is crucial for ensuring safety and compliance. The NEC provides comprehensive guidelines for electrical installations, covering various aspects from wiring methods to overcurrent protection. One important aspect is grounding. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. All electrical equipment should be properly grounded. This includes metal enclosures, appliances, and lighting fixtures. Another important aspect is overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The size of the overcurrent protection device should be appropriate for the size of the circuit conductors. Wiring methods are also important. The NEC specifies different wiring methods for different applications. For example, non-metallic sheet cable or NM cable is commonly used for residential wiring. However, it is not permitted to be used in certain locations, such as in wet or damp locations. Conduit is a type of wiring method that provides physical protection for electrical conductors. It is commonly used in commercial and industrial applications. The NEC also covers the installation of lighting fixtures. Lighting fixtures should be installed in accordance with the manufacturer's instructions. They should be properly supported and grounded. The NEC also specifies the minimum lighting levels for different areas. For example, the minimum lighting level for a hallway is 10-foot candles. The NEC is a complex document, and it is important to consult it when performing electrical work. It is also important to hire a qualified electrician to do the work if you are not comfortable with it. Understanding basic electrical concepts such as voltage, current, and resistance is also essential for working safely with electricity. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of electrical charge. It is measured in ohms. Ohm's law states that the voltage across a resistor is equal to the current through the resistor times the resistance of the resistor. This law can be used to calculate the voltage, current, or resistance in a circuit. For example, if a resistor has a resistance of 10 ohms and a current of 2 amps is flowing through it, the voltage across the resistor is 20 volts. Power is the rate at which electrical energy is transferred. It is measured in watts. The power dissipated by a resistor is equal to the voltage across the resistor times the current through the resistor. For example, if a resistor has a voltage of 20 volts across it and a current of 2 amps is flowing through it, the power dissipated by the resistor is 40 watts. Electrical circuits can be either series circuits or parallel circuits. In a series circuit, the components are connected in a single path. The current is the same through all of the components in a series circuit. The voltage is divided among the components in a series circuit. In a parallel circuit, the components are connected in multiple paths. The voltage is the same across all of the components in a parallel circuit. The current is divided among the components in a parallel circuit. Understanding the difference between series and parallel circuits is important for troubleshooting electrical problems. For example, if one component fails in a series circuit, the entire circuit will stop working. However, if one component fails in a parallel circuit, the other components will continue to work. When working with electricity, it is important to use appropriate safety equipment. This includes insulated tools, safety glasses, and gloves. It is also important to be aware of the potential hazards of electricity, such as electric shock and arc flash. Electric shock can occur when a person comes into contact with a live electrical conductor. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit. It is important to follow all safety precautions when working with electricity to prevent these hazards. The NEC provides detailed guidelines on the installation and maintenance of electrical systems to minimize these risks. These guidelines cover topics such as wire sizing, overcurrent protection, grounding, and bonding. Wire sizing is important to ensure that the conductors are large enough to carry the intended current without overheating. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Grounding and bonding are important for providing a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The NEC also addresses specific requirements for different types of electrical equipment, such as lighting fixtures, appliances, and motors. These requirements are designed to ensure that the equipment is installed and used safely. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It is important to stay up to date on the latest version of the NEC to ensure that your electrical work is compliant with current codes and regulations. In addition to the NEC, there may be local codes and regulations that apply to electrical work in your area. It is important to check with your local building department to determine the applicable codes and regulations. Hiring a qualified electrician is always recommended for electrical work that you are not comfortable with or that requires specialized knowledge or equipment. A qualified electrician will be familiar with the NEC and local codes and regulations, and will have the necessary skills and experience to perform the work safely and correctly. When selecting an electrician, it is important to check their qualifications and experience. Ask for references and check their license status with your local licensing board. It is also a good idea to get multiple bids for the work to ensure that you are getting a fair price. The electrical safety is a shared responsibility. Homeowners, electricians, and manufacturers all have a role to play in ensuring that electrical systems are safe and reliable. By following the NEC and local codes and regulations, using appropriate safety equipment, and hiring qualified electricians, we can minimize the risks associated with electricity and create a safer environment for everyone. Consider the specific example of a homeowner wanting to install a new ceiling fan. Firstly, the homeowner should turn off the power to the circuit at the breaker. Secondly, the homeowner should use a voltage tester to verify that the circuit is de-energized. Thirdly, the homeowner should carefully follow the manufacturer's instructions for installing the ceiling fan. Fourthly, the homeowner should ensure that the ceiling fan is properly supported and grounded. Fifthly, the homeowner should use wire connectors that are rated for the size and type of wires being used. Sixthly, the homeowner should carefully tighten all of the connections. Seventhly, the homeowner should turn the power back on at the breaker and test the ceiling fan to ensure that it is working properly. If the homeowner is not comfortable with any of these steps, they should hire a qualified electrician to do the work. Another example is a homeowner wanting to replace a light switch. Firstly, the homeowner should turn off the power to the circuit at the breaker. Secondly, the homeowner should use a voltage tester to verify that the circuit is de-energized. Thirdly, the homeowner should carefully remove the old light switch. Fourthly, the homeowner should connect the wires to the new light switch in the same way that they were connected to the old light switch. Fifthly, the homeowner should carefully install the new light switch in the wall box. Sixthly, the homeowner should turn the power back on at the breaker and test the light switch to ensure that it is working properly. If the homeowner is not comfortable with any of these steps, they should hire a qualified electrician to do the work. These examples illustrate the importance of following safety precautions and consulting the NEC when performing electrical work. Even seemingly simple tasks can be hazardous if not done correctly. By taking the time to learn about electrical safety and following best practices, homeowners can protect themselves and their families from electrical hazards. The NEC also provides guidance on the selection and installation of overcurrent protection devices. The size of the circuit breaker or fuse should be appropriate for the size of the circuit conductors and the load that the circuit is expected to carry. Using an overcurrent protection device that is too large can allow the circuit conductors to overheat, which can lead to a fire. Using an overcurrent protection device that is too small can cause the circuit breaker to trip or the fuse to blow frequently, which can be inconvenient. The NEC provides tables that specify the allowable ampacity of different types of conductors. These tables take into account the size of the conductor, the type of insulation, and the ambient temperature. When selecting an overcurrent protection device, it is important to consult these tables to ensure that the device is properly sized for the circuit conductors. The NEC also provides guidance on the installation of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electric shock by detecting small amounts of current leakage to ground. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. GFCIs should be tested regularly to ensure that they are working properly. To test a GFCI, press the test button on the device. This should cause the GFCI to trip. If the GFCI does not trip, it should be replaced. The NEC also provides guidance on the installation of arc fault circuit interrupters, or SIs. SIs are designed to protect against fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when there is a break in the insulation of a wire. SIs are required in certain locations, such as bedrooms and living rooms. SIs should be tested regularly to ensure that they are working properly. To test an SI, press the test button on the device. This should cause the SI to trip. If the SI does not trip, it should be replaced. Electrical safety is an ongoing process. It is important to regularly inspect electrical systems for any signs of damage or deterioration. Worn or damaged wiring should be replaced immediately. Loose connections should be tightened. Overloaded circuits should be corrected. By taking these steps, you can help to ensure that your electrical system is safe and reliable.